Thanks very much for having me. This is my first TTF conference. We've had some excellent presentations so far already today and some great presenters. Unfortunately, you're stuck with me before you get your coffee. But really today, for the next sort of 15 minutes, I'd like to chat about some of the challenges that we face for network adaptive control systems. And we've talked about these already today. Scoot is predominantly the adaptive control system used in the UK, and many other countries around the world use Scoot as well. And I want to take a little bit of a step back of what are some of these challenges. We did a study a few years ago, and then really how have Yunex responded to that in terms of the sort of network adaptive control system. So hopefully we'll tie a few things together. So back in 2019, Yunex commissioned a study with the University of Southampton, and we said we want to discuss with local authorities what are the future challenges that you're sort of facing. What way do you want UTC to go in the future? And this was international, so we worked with local authorities from over the world. There was 5 continents involved, which sounds very grand. There was sort of 16 local authorities interviewed, and these were like semi-structured interviews, so it was the same questions being asked. There were sort of hour-long sessions really trying to extract some information. Now this was individual interviews, so the people weren't sort of collaborating as such. It was a Delphi study, and basically it was trying to understand what are the future problems. And the cities that were represented were of various sizes, so it wasn't just all the sort of mega cities, it was some small ones as well. I say sort of focused on the next sort of 5 to 10 years. And there was 3 key themes that came out, and they've already been covered in the presentations this morning, which is quite nice. There's a lot of synergies between the presentations, but it was sustainable transport, it was sort of resources and resource constraints, and connectivity. So I say this was from 2019, and we're kind of now going to have a look at some of the things they said back then and sort of say, do we still believe that? Were they a good forecast? Were they a bad forecast? I'll let you guys be the judge of that. But let's just quickly go through these 3 things, and then we'll sort of tie it all together in the next part. People at the back probably can't read this at all, but I'll read out a few of them at least for you. So sustainable transport, some of the themes that came out were that we're sort of moving away from the car is king scenario. So it's very much looking at multimodal. We'll care more about active travel. We'll care more about sort of cyclists, pedestrians, buses. We want to have the ability to optimize all modes of transport. And again, these themes have come up this morning, which is good. So I think their forecast was not too bad, shall we say. We want to look at freight and how that sort of moves within the city and maybe control at different times of day. And we want to look at air quality and sort of improving, sort of reducing emissions in our sensitive areas. So these were some of the key themes, which isn't a big surprise, and I think we've all been talking about them already, as I say. So I think that was quite a good forecast. In terms of resources, well, we sort of said as well, there's a bit of a skills shortage in our industry, and actually knowing the technical detail is a challenge, and sort of bringing that next generation into the ITS world. We need to, yes, train them, but we need to make our systems easier to use. And you don't want to have the complexity of some of the legacy systems that are out there. We want to make it easy, intuitive, ready for the 21st century. And even on a hosting side, there was the theme of sort of cloud hosting, moving things towards the cloud. So you're not managing the infrastructure, the servers that are sitting in your offices as such. So again, I think not a bad forecast of kind of where we are today. I do appreciate this 2023, so it's only 4 years forecast, so maybe I should have waited a year to do this, but I thought I'd highlight it a little bit today. And the last big theme was connectivity. Again, hot topic of today. We want to be able to connect to vehicles and road users and provide them with useful information. There was a bit of a theme about incident detection. I'll probably not focus on that one too much, but someone said it can be 3 hours before we know of an incident. I think times are moving on and incidents are getting detected faster, but again, an interesting challenge to overcome. And a really general statement, a lot more information, whatever it might be. So trying to sort of fuse all this information, this was again a few years ago, V2X, that kind of how are we getting that connected vehicle information coming in, IoT, the legacy equipment of loops, how do we bring that together into some form of understanding? So this is what problems were sort of being laid out in front of us a few years ago. And now I think I'll not be too subtle about it. I'll go through them and you'll see the synergy throughout the sort of how have we responded to these challenges, because we only have 10 more minutes or so. But we have tried to tackle these challenges with what we see as a sort of the next generation of network adaptive control, which is what we're calling Fusion, is our new product. But this is very much our vision for how we will move away from Scoot, which has been with us and served us well for decades, but how do we take it to that next level, and how do we actually improve from where we are today? So what is Fusion? We're trying to use existing infrastructure that's out there. So if you start on the right-hand side, you've kind of got, you definitely never see this at the back, so apologies, but if I say it out loud, hopefully you'll hear it. In the towns and cities, we have detectors. We have data that's connected to on street, looking for vehicles, for pedestrians, for cyclists. We've got room for improvement there, and there's more technologies coming in, but there's detectors on street. That information gets passed into the sort of core UTC system, so we get raw information, and we pass that into Fusion. And following on from Mark's presentation, wherever he's sitting, this is what we call our sort of digital twin, to use that term here, where we build up this model and say, what is the state of the network? So for a region that you're trying to control within your city, we build up where are all the vehicles, where are the pedestrians, what do we think is going to happen over the next 10 minutes, hour, day, and we start making these forecasts of where and what's happening on the network, and we build up that picture. And from that, we can then make some changes and say, okay, so what's currently running on your signals? What's the best thing to do? And we run different optimizers. I'll do a talk on that another day. But ultimately, we can make changes to what's currently happening to respond to the policy that the city set. So we can adapt the plans live, real time, and then send that back and make changes. So all of this, I probably should have said this at the start of the slide, but we're working in partnership with Transport for London, and we've been doing that for the last few years, looking to sort of meet some of those challenges that I laid out at the start. And if we think about what are the benefits of Fusion, it's sort of really built on the principles of what the challenges were. So we've got four benefits listed here, and I'll go through them in a couple of slides. So we've got dynamic prioritization for individual road users. So you could prioritize buses, cyclists, pedestrians, which again is in response to that first challenge. We've got reduced complexity for the configuration and validation. We want to make life easier for new people coming into the industry and existing people in the industry to configure and set up the system to get the best out of it. We can look at CITS use cases, improve safety and driver comfort. And again, we've had some presentations on that today, but that's what Fusion will enable, or will help to enable and play a part in that role. And then equally, we care about performance, right? We want it to actually be good and actually better than the old systems that's been out there, like Scoot, that's been around for many years. So, first one, Fusion looking for the movement of people and not just cars, and we want to help different modes through the network. So in our digital twin, as I sort of say, we look at the different modes that we're able to detect and bring that into Fusion. It's not sort of designed around the sort of degree of saturation, looking just occupancy of loops that traditionally, Scoot has used for the last number of decades. But this is a political problem as much as technical. So we've got three different pictures. We've got cars, public transport, pedestrians, bicycles, and others. And actually, it's still a capacity problem ultimately. Who do you give the green light to and for how long? And that's the sort of the policy that's there. Fusion's not doing magic. You've got to work with the policy that the city wants to implement. So some sites you may care a lot about getting cars through the junction. Some sites you want to get buses through as soon as they're detected. You want to get them straight through. Others, it might be, highly pedestrian area. You want to get pedestrians through quicker and get the cycle times down. So we want to give the tool that lets you do that. So that's what Fusion's really designed around. Model the different modes, if you can detect them, bring them into Fusion, and then give the sort of levers and the tools that you need to be able to optimize for them, or prioritize if you need to be a bit more disruptive. So in my really not subtle way, this is the sustainable transport problem that we sort of highlighted from a few years ago. We want to be able to optimize all modes of traffic, not just cars. The next one is about reducing the complexity and having smoother configuration and validation workflows. So this has been designed from the start as a modern UI. We don't expect our traffic engineers to learn literally hundreds of commands for controlling Scoot. You can do this through a UI, it's intuitive, and you're able to easily swap between things like different profiles for different times of day, set up strategies, be able to, if you were able to see the GIF, you'd be able to see you can just easily change between, a morning peak, an incident response plan, an evening peak, whatever you need to set up. And you don't need to have these long list of commands to remember anymore. You can do changes offline, and then the system will obviously do a live update when you make the changes and commit them, building on the sort of some of the problems that we've had of the past of older systems and how we can now actually take it into the 21st century ultimately. We want to visualize what's happening in our digital twin, to stick with that theme. So you can sort of see, I know it's just colors, but it's that kind of, you can see where the cars are, what approach they're on, what mode's coming in, and your position of the bus, for example, and how far away it is from the stop line. And, this is our sort of beta view of how we want to show that digital twin, but we want to put this on a map layer and be able to make it a lot more intuitive. And I think that's where the UTMC part comes in. How do we share our digital twins, like you said, and how do we actually overlay it and make that relevant for other use cases as well? But, this is our use case. We want to know what's there now and what's going to be there in the future so that we can optimize for traffic control. But we've got a wealth of historical data coming in here as well, so you can just look up the sort of what the flows are, the cycle times that's been running, what the demand has been, what the delay is, and we can sort of display that graphically and output it. So again, in my not so subtle approach, this is a bit of a response to the resource constraint, the challenges. We want to make it easier to use, and anyone that comes into the industry, it's a bit more intuitive and easy to understand. So key benefit 3, looking at how Fusion can sort of increase driver safety and comfort with CITS use cases. So gloss has been talked about already. We've had some demonstration of in-vehicle signage. Well, actually, we want to be able to publish SPAT information. So again, Fusion's been able to be designed to be able to publish SPAT information and deliver the glossal use case. And equally, you could have other use cases in the connected world where you could have like buses requesting priority, and we've been doing this in Belgium, where you get the request for priority, and then Fusion will say, yes, that priority request has been granted or has been rejected. So again, providing useful information to the vehicles and the road users that has real benefits to help the priority use case, to help the glossal use case, and actually smooth out those traffic flows. So the last bit of non-subtlety. So this is the connectivity theme, right? How do we respond to that? Well, actually, that's what Fusion is designed to tackle and be able to publish that information and share it in a useful way. And to say, lastly, we want to talk briefly about performance, because that's important too. We can't just sort of say, great, we've got this new shiny system that's meeting all these problems, but it's rubbish. I don't think that will work for anyone. So we've been doing lots of trials with London. As I say, they're our partner here. We've got a number of regions. I'll show them in a moment. And we've been seeing typically sort of 10 to 15% reduction in delay for these sites in London that we've been running. And we've been doing more trials in Hampshire. I've actually got a slide for that next. I should have put that one up. So we've got, 11 sites with 3 regions in London. We've been running these for the last few years. We've got a lot more data here, on and off, to be able to establish baselines. And London have quite grand ambitions, as you'd expect, being our partner in it, to roll this out across London. and this will be a phased approach as we'll be able to move away from Scoop and replace it with Fusion, and that's very much the ambition as the systems go live this year. We wanted to demonstrate Fusion outside of London, so it wasn't just a TFL demonstration. It was also in Hampshire, so we've got three regions running in Hampshire. That's 15 sites, and we're very much in the analysis phase. So we've been turning Fusion on for a couple of weeks, turn Scoot on, do comparisons using like journey time data from here. So we're able to do some analysis and some of the Scoot generated data. So this has been quite an exciting phase for us. We've been able to demonstrate the improvements. So we're sort of meeting the challenges and still having performance gains. And this is just the start for us. This is this first release as such of Fusion. And now we want to be able to building that and add more functionality and more benefits, especially as detector technology changes going into the future. So the last slide for me was just a recap. So looking at what the key sort of themes were from when we interviewed the local authorities, or the University of Southampton did the interviews, as I say. So we have sustainable transport, motivations to prioritise different modes and optimise different modes. That's what Fusion's working towards. The resource constraints, we want to simplify the workflows and make it easier to use. How we can be more connected and publish relevant information is very much the sort of SPAT use cases and priority requests. And we're seeing some significant performance gains as well. So this is me done. This is very much Fusion and how we've responded to some of the challenges over the last few years. Happy to take any questions, or do feel free to come and see us at our stand.